Hello everyone, a very warm welcome to Smiley Kids channel. Today we're going to see Class 10 Mathematics Chapter 2 Polynomials Exercise 2.2. So let's begin. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. So the first one is x squared minus 2x minus 8. So first we're going to find out the zeros of this particular quadratic polynomial. How do we do that? First, what is the coefficient of x square? It is 1. And what is the constant term? It is minus 8. It's not 8. It is minus 8. So first we're going to multiply the coefficient of x square with a constant term of the same quadratic polynomial. So it is 1 times minus 8, which is minus 8. Now we're going to find out the factors of minus 8. So factors of minus 8 can be minus 4 times 2. Right, or it can be 2 times minus 2 times 4, or it can be minus 8 times 1, or 1 time minus 1 times 8. Now we have so many factors, isn't it? Now we are going to find out one such factor which can result us in minus 2x. That means, let's suppose say the first one, right, minus 4x. Let's suppose say plus 2x. So now we're going to subtract it and we result minus 2x, and that's what we require. If we take a look at the other factors, let's suppose the second one. So it is minus 2x plus 4x. In this case, the resultant answer will be 2x, but we require minus 2x. So we're going to add or subtract these factors in order to get the minus 2x. This is called the splitting the middle term, isn't it? Now if we take a look at the third one, that is minus 8 times 1. So it's going to result as minus 8x plus 1, which is going to be minus plus minus, minus 7x. This is not at all what we are going to acquire, right? Even the fourth one will result you the wrong answer. So we're going to take the first one into consideration and split the middle term, right? So it is x square minus 4x plus 2x minus 8. What have we done? We have just multiplied the constant term with the coefficient of x square, and we acquired the minus 8, and then we found out the factors, and according to the factors we have split the middle term, isn't it? Now we're going to further solve this. We have x square minus 4x plus 2x minus 8. Now in the first one, that is x square minus 4x and 2x minus 8. So in the x square minus 4x, I can take out x common, isn't it? And in brackets we have x minus 4 plus in 2x minus 8, I can take out 2 common, right? And I'll be left out with x minus 4 in the brackets. Have a look at this. X into x will be x square minus x into 4 will be 4x, right? Minus 4x, and then plus 2 into x will be 2x, and minus 2 into 4 will be 8. This is similar to this one, isn't it? So we have just taken out the common ones. Now here we have x times x minus 4 plus 2 times x minus 4. What do you find common? We find x minus 4 common. So let's take out x minus 4 common. And then here we have x plus 2, isn't it? So it's going to be x plus 2. Now we arrived to x minus 4 times x plus 2. Now how do we find out the zeros? X minus 4 is equal to 0. So x will be what? 0 plus 4, and x will be equal to 4. Now one of the zero of this particular quadratic polynomial is 4, isn't it? Then we have x plus 2 is equal to 0. That means whatever we got, x minus 4 and x plus 2, we are going to equate it to 0, isn't it? Now x plus 2 is equal to 0, x is equal to 0 minus 2, isn't it? Now 0 minus 2 is going to give us minus 2. Now other 0 we got is minus 2. So the zeros of this particular quadratic polynomial are 4 and minus 2. So what are the zeros of x square minus 2x minus 8? 4 and minus 2 are the zeros of this particular quadratic polynomial. Now wait, we are not yet done with the question. They are asking us to verify the relationship between zeros and the coefficients. Now, let's suppose say one of the zero is alpha and the other is beta. That means alpha is 4 and beta is minus 2. This alpha and beta are nothing but the zeros of the quadratic polynomial x square minus 2x minus 8, isn't it? Now we're going to verify the relationship between the zeros. We know the fact that alpha plus beta is equal to minus b by a. Now we know that alpha and beta are what? 4 and minus 2. So 4 plus minus 2 is going to give you minus b by a. Here we know that in this particular quadratic polynomial, which is x square minus 2x minus 8, a is what? 1, b is minus 2 and c is minus 8, isn't it? So the coefficient of x square is 1, which is a, and coefficient of x is minus 2 and the constant term is minus 8. Now, this alpha plus beta must be equal to minus b by a. Then only we can verify the relationship between the zeros and the coefficients, isn't it? Now, what is minus b? Here we know that the value of b is minus 2. So, it is minus of minus 2 upon a is what? 1, isn't it? Now, when we further solve this, we get 4 plus minus 2. Now, plus minus turns out to be minus, right? So, 4 minus 2 is equal to, here minus and minus get cancelled. So, we'll be left out with what? 2 upon 1, which is nothing but your 2. Now, 4 minus 2 is 2, right? 2 is equal to 2. Hence, we verify the relationship between the sum of the zeros and the coefficients. Now let's have a look at the product of the zeros and its coefficients. Now we know that alpha beta, that means the product of zeros, is equal to c by a. And we know the zeros are 4 and minus 2, isn't it? So 4 times minus 2 must be equal to c by a. Then only we can verify the relationship between the product of zeros and the coefficients, isn't it? And we know that the value of c is minus 8. So minus 8 upon, what is the value of a? It is 1. Now, when we solve this further, 4 times minus 2 is minus 8 is equal to minus 8 by 1 is minus 8. Again, we have successfully verified the relationship between the product of zeros and the coefficients. So this is how we are going to verify the relationship between the zeros and coefficients. Once we find the zeros of the quadratic polynomial, then we are going to take this particular thing saying that alpha plus beta is minus b by a and alpha beta is equal to c by a, and we're going to substitute the values and verify the relationships in this way. Now let's have a look at the second one, which says 4s square minus 4s plus 1. Now here first let's multiply the constant term and the coefficient of x square. So here x square means s square, isn't it? We know that the quadratic polynomial will be in the form ax square plus bx plus c, isn't it? Now we're going to find out the zeros using the splitting the middle term method by factorizing them, isn't it? So now 4 times 1. 4 times 1, which is 4. Now we are going to find out the factors of 4 that will be equal to minus 4s, isn't it? That is what we call the splitting of middle term. Now the factors could be 2 times 2, isn't it? Or it can be minus 2 times minus 2, or it can be 4 times 1, or it can be minus 4 times minus 1. Now let's have a look at the first possibility, 2 times 2. Now 2x plus 2x will be what? 4x. But that's not what we are expecting, right? We are expecting minus 4x or minus 4s, right? Then we have the second one, minus 2s plus minus 2s, let's suppose say. Then it will result you in minus 4s, isn't it? And that's it, we got the value. So it is the second possibility will give you the right answer. So it is going to be 4s square minus 2s plus minus 2s plus 1. This is going to result you in 4s square minus 2s minus 2s plus 1. Now let's take out common, right? So here in the first one and the second one. In the first one we are able to see that 2s can be taken out the common, right? So we'll be left out with 2s in brackets minus 1. So here again I'm taking 1 as common and will be left out with 2s minus 1. So here we are able to see that 2s minus 1 is common. So I'm going to take it out 2s minus 1. And again we're able to see that 2s minus 1 is common. So 2s minus 1. Now this is nothing but 2s minus 1 must be equal to 0. Right? So s will be equal to what? 1 upon 2. Again the same case with the second one as well. Right? So it's going to be 2s minus 1 is equal to 0 and s will be equal to 1 upon 2. Now, what are the zeros of this particular quadratic polynomial 1 upon 2? Now, what are the zeros of 4s square minus 4s plus 1? They are 1 by 2 and 1 by 2 respectively. Now, we know that alpha plus beta is equal to minus b by a. Because we're going to verify the relationship between the zeros and the coefficients. So first we're going to find out the sum of the zeros and its coefficients, isn't it? Now we know that alpha is equal to 1 by 2 and beta is also equal to 1 by 2. Now this means 1 by 2 plus 1 by 2 is equal to minus b by a. Here what is minus b by a? We know that a is what? 4. B is minus 4 and c is 1. So here minus b by a will be minus of minus 4 upon 4. Isn't it? Now, here 1 by 2 plus 1 by 2 will result you what? 2 by 2, isn't it? Which is equal to, here minus and minus get cancelled, 4 by 4. Now, 2 by 2 is what? 1. 4 by 4 is what? 1. So, we have successfully verified the relationship between the sum of the zeros and its coefficients. Now, we're going to find out the product of the zeros and its coefficients. Now, what is product of zeros? Alpha beta is equal to c by a. And we know that alpha is 1 by 2, beta is also 1 by 2. So, it's going to be 1 by 2 times 1 by 2 is equal to what is c? 1 by what is a? 4, isn't it? Now, 1 by 2 times 1 by 2 is nothing but 1 by 4. 1 by 4 is equal to 1 by 4. So again, we have successfully verified the relationship between the product of zeros and the coefficients. So this is how we're going to verify the relationship between the zeros and its coefficients. Six x square minus 3 minus 7x. If you clearly observe the question, it is not in the form of the standard form of a quadratic polynomial. So let's convert into the standard form. What is the standard form? Ax square plus bx plus c is the standard form of a quadratic polynomial. So first let's convert this particular given quadratic polynomial into the standard form. We get 6x square minus 7x minus 3. Now we are going to acquire the zeros and then find out the relationship or verify the relationship between the zeros and the coefficients. Now multiply the constant term with the coefficient of x square. So coefficient of x square is 6 and constant term is minus 3, which is minus 18. Right? When we multiply, we get minus 18. Now we're going to find out the factors of this. So first we have minus 2 times 9. Then we have minus 9 times 2. Isn't it? Or we have 1 times minus 18 or minus 1 times 18. So all these particular factors are going to result you in minus 18. Now let's see one by one which is going to satisfy our splitting the middle term procedure. So first we have minus 2 times 9. Now minus 2 times 9. So minus 2x plus 9x will give you what? Minus plus minus, we are going to get 7x, isn't it? But if we do it like minus 2x minus 9x, so in the first case we have subtracted it, now we are, in the first case we have added it and now we are subtracting it, right? So we get minus 11x, which is not actually what we want, right? We want minus 7x. So the first one is not verifying our this particular splitting the middle term procedure. So then we're going to see the second one. So minus 9x plus 2x. First we are adding it. So we get minus 7x, which is completely satisfying our splitting the middle term procedure. So I'm going to take out minus 9x and 2x. So it's going to be 6x square minus 9x plus 2x minus 3. And now I hope we can take something common and we can find out the zeros. Now, out of the first one, 6x square minus 9x, we can take out 3x common, isn't it? So it's going to be 3x common. So it will be 2x minus 3. Then in the second one, I'm taking 1 common out of it. So it will be 2x minus 3 because we don't have anything common to be taken out in the second one. So this is how we are ending up our answer with, and we are able to find out that 2x minus 3 is common. So 2x minus 3 will be the first one. And then we have 3x plus 1, isn't it? 3x plus 1. Now we're going to equate both of them to 0. So 2x minus 3 is equal to 0. X will be equal to what? 3 by 2, isn't it? So the first 0 we have is 3 by 2. And the second one, 3x plus 1 is equal to 0. Then x will be equal to minus 1 upon 3. So the second 0 we got is minus 1 upon 3. Now further we're going to verify the relationship between the zeros and the coefficients. Now here we have alpha as 3 by 2 and beta as minus 1 by 3. Now we're going to verify the relationship. For that we need the value of a, b and c. The value of a is 6. B is minus 7 and C is minus 3 according to the question. Right. Now we know that alpha plus beta is what? Minus B by A. And we know that here alpha is 3 by 2 and beta is minus 1 by 3. So it's going to be 3 by 2 plus minus 1 by 3 is equal to minus of minus 7 upon 6 on substituting the values of B and A. Right. So on solving this particular expression 3 by 2 minus 1 by 3, on finding the LCM and then subtracting, we get 7 by 6, which is equal to 7 by 6. So we have successfully verified the relationship between the sum of the zeros and its coefficients. Now we're going to see the product of the zeros. We know that the product of the zeros will be what? Alpha beta is equal to C by A. And we know that alpha is 3 by 2 and beta is minus 1 by 3, which is going to be equal to, what is value of C? Minus 3, isn't it? So minus 3 upon 6. Now here 3 and 3 get cancelled. We'll be left out with minus 1 by 2. Right. We'll be left out with minus 1 by 2. And here also we'll be left out with minus 1 by 2. So again, we have successfully verified the relationship between the zeros and the coefficients. Right. So in this way, we have verified the relationship between the product and as well as the sum of the zeros and the coefficients. Then we have 4u square plus 8u. And wait, this is again not in the standard form. The standard form is ax square plus bx plus c. Right. Now, we can clearly observe in the question that a is 4, b is 8 and there is no constant term, that is c equal to 0. Now, we are going to find out the zeros of this particular quadratic polynomial. Now out of this 4u square plus 8u, we don't have the constant term. So we're going to not split the middle term, right? That's not going to work. So here out of this, we're going to take something common. So we can take 4u common and we'll be left out with u plus 2, isn't it? Now 4u must be equated to 0 and u plus 2 must be equated to 0. So it's going to be 4u is equal to 0 and u plus 2 is equal to 0. Now here u will be equal to what? 0 by 4. U will be equal to 0. And then here u will be equal to 0 minus 2 and u will be equal to minus 2. Isn't it? So the values or the zeros of this particular quadratic polynomial 4u square plus 8u are 0 and minus 2. Now let's verify the relationship between the zeros and the coefficients. Now alpha is 0 and beta is minus 2. Now we are going to verify the relationship. Alpha plus beta is equal to minus b by a. And we are sure about the fact that a is 4, b is 8 and c is 0. Now alpha is what? 0 plus beta is minus 2, which is equal to what is minus b by a? Minus 8 by 4. Right? When we solve this further, 0 minus 2 will be equal to minus 2, equal to 4 times 1, 4 times minus 2. So minus 2 equal to minus 2. Hence, this is how we have verified the relationship between the sum of the zeros. Now we're going to take a look at the product of the zeros. What is the product of zeros equal to? Alpha beta is equal to c by a. That is the sum of the zeros equal to c by a. What is alpha? 0 times minus 2, because we know that alpha is 0 and what is the value of beta? It is minus 2. So alpha times beta, which is 0 times minus 2 equal to what is c? 0, right? And what is a? 4. And we know that any number multiplied by 0 is 0. And what is the value of 0 divided by 4? It is 0. So this is how we have verified the relationship between the product of zeros as well. Now here we have t square minus 15. So here we are able to clearly observe that the value of a is 1, b is 0 and c is minus 15 according to the question we have. Now how do we find out the zeros of the quadratic polynomial? Just by looking at this. So first equate this expression to 0. T square minus 15 equal to 0. Now t square will be equal to plus 15. When I send this minus 15 to the other side, it turns out to be plus 15, right? And when I send the square to the other side, it turns out to be square root of 15. And always remember, the square root can be positive or negative. So the two zeros of this particular quadratic polynomial t square minus 15 are plus root 15 and minus root 15. So what are the zeros of this particular quadratic polynomial? Plus root 15 and minus root 15. So alpha is plus root 15 and beta is what? Minus root 15. Now, we know that alpha plus beta is equal to minus b by a. And what is the value of a? It is 1, b is 0 and c is minus 15. Now alpha is root 15 or plus root 15 plus what is beta? Beta is minus root 15. So minus root 15, which is equal to what is minus b by a? Minus 0 by 1. Now when we solve this further, root 15 minus root 15 will give you 0 and then we have 0 by 1, which is again 0. So this is how we have verified the relationship between the sum of the zeros and its coefficients. Now let's have a look at the product of the zeros and the coefficients. Now alpha beta, that is the product of zeros, will be equal to c by a. And what is alpha? Root 15. What is beta? Minus root 15. Which is equal to what is c? C is minus 15 upon what is a? 1. Now root 15 times minus root 15 will give you what? It is nothing but root minus of root 225 equal to minus 15, isn't it? And what is the root of minus root 225? It is nothing but minus 15. So minus 15 is equal to minus 15. So this is how we have verified the relationship between the product of the zeros and its coefficients. And then we're done. Then we have the sixth and the last one of this particular sub questions. So it says 3x square minus x minus 4. Now again, we're gonna follow the splitting of the middle term procedure. Multiply the constant term with the coefficient of x square. So it's gonna be minus 4 times 3. Now minus 4 times 3 is nothing but your minus 12. Now find out the factors of minus 12. So it can be minus 3 times 4, or it can be minus 4 times 3, right? It can be minus 12 times 1, or it can be 12 times minus 1. Right. Now we're going to see which is going to satisfy our splitting the middle term procedure. Now first we're going to take minus 3 and 4. Let's first add them. So minus 3x plus 4x will give you what? X, isn't it? Minus plus, we are going to subtract it and then we get x. And that's not what we want. We want minus x. Let's suppose say I am subtracting the same factors. So minus 3x minus 4x, which is going to give us minus 7x, which is not at all what I want. Right? Then we have a look at the second one, minus 4 and 3. So first I'm going to add them. So minus 4x plus 3x. Now I'm going to subtract them and then we have right. So it's going to be minus 4 plus 3, isn't it? So subtracting minus 4 plus 3 will give you what? Minus 1 or minus x in fact, right? Minus 1x or minus x. So and that's what we want. So here I'm going to write down 3x square minus 4x plus 3x minus 4. Right. Now we're going to take out something common out of all this. So in the first one, can we take anything common? We can take x common, right? We are left out with 3x minus 4. And in the second one, we can take out 1 common and we'll be left out with 3x minus 4 again. And we are able to see that 3x minus 4 is common, isn't it? So we're going to take out 3x minus 4. And then we have x plus 1. So x plus 1. And now we're going to equate both of these expressions to what? We're going to equate them to 0. Then we get what? 3x minus 4 is equal to 0. And x will be equal to what? X will be equal to 4 upon 3. And then we have x plus 1 equal to 0. X equal to minus 1. So what are the values of alpha and beta of this particular quadratic polynomial? 4 by 3 and minus 1. Now alpha is equal to minus 1 and beta equal to 4 by 3. Now again alpha plus beta, sum of zeros is equal to minus b by a. And what is alpha? Minus 1 plus 4 by 3. The value of beta is 4 by 3, which is equal to what is a, b and c? A equal to 3, b equal to minus 1 and c equal to minus 4 according to our quadratic polynomial which is given, isn't it? Now, what is minus b? Minus of minus 1 upon what is a? 3. Right. So upon solving this, we take LCM, right? First, we're going to take out the LCM. So it's going to be minus 3 plus 4 is equal to 1 by 3. Right. Now on solving minus 3 plus 4, we get 1 by 3 equal to 1 by 3. And that's how we have verified the sum of the zeros and its coefficients. Now let's have a look at the product of the zeros and its coefficients. Right, so alpha beta is equal to c by a, that is the product of zeros is equal to c by a. And we know that alpha is -1 and beta is 4 by 3, which is going to be equal to C by A, which is -4/3. Now, what is -1 times 4? It's nothing but -4. Right? So, -4/3 is equal to -4/3. And this is how we have verified the relationship between the product of the zeros and the coefficients. And we are done with the first question. Now moving on to the second one. So the second question says, find the quadratic polynomial each with the given numbers as the sum and the product of its zeros respectively. So here we are being given with the sum of the zeros, that is alpha plus beta is being given as 1 by 4. And we are being also given with the product of zeros. So product of zeros, that is alpha beta or alpha times beta is given as -1. Now with this given values, they are asking us to find out the quadratic polynomial with the sum and the product of zeros being 1 by 4 and -1 respectively. Right. Now how do we find out the quadratic polynomial? You must always remember that the quadratic polynomial is in this way: x square minus alpha plus beta into x plus alpha beta. This is the standard form of the quadratic polynomial, isn't it? Now, x square will be as it is. And remember that you're multiplying this particular thing with k, right? K into x square minus alpha plus beta into x plus alpha beta. Now, we have k into x square minus, here we know that alpha plus beta is what? Minus, so it's going to be minus, alpha plus beta is 1 by 4. So it's going to be 1 by 4 times x plus, what is alpha beta? Alpha beta is -1, isn't it? Now on simplifying this further, we get k multiplied by x square minus 1 by 4 into x, right, or x by 4 plus, so plus minus will turn out to be minus, isn't it? So -1. Now this 4 over here can be removed by multiplying. So here we can take the value of k as 4 and then we can multiply the entire equation by 4 and then we can delete this particular 4 as the denominator of x, right? So let's suppose say k equals to 4. So it's going to be 4x square minus 1x or minus x minus 4. We have multiplied this entire equation with what? We're going to multiply it with 4. So 4 times x square is 4x square minus 4 times x by 4 is going to be minus x minus 4 times -1 is going to give you -4. So the required quadratic polynomial is 4x square minus x minus 4. Then we have √2 and 1 by 3. Alpha plus beta is √2 and alpha beta is 1 by 3 according to the question. And we know that k into x square minus alpha plus beta into x plus alpha beta is the standard form. Right. Now we're going to substitute the values of alpha plus beta and alpha beta respectively. So we get k into x square minus √2x, because alpha plus beta is √2, plus then we have alpha beta whose value is 1 by 3. Now here I want to eliminate the denominator, which is 3. So what I'm going to do, I'm going to multiply the k, or I'm going to substitute the value of k as 3 and then I'm going to multiply this entire equation by 3. So let's suppose say k is 3, then I'm going to multiply 3 with the entire equation x square minus √2x plus 1 by 3, which is going to result me 3 into x square is 3x square minus 3 into √2x is going to be minus √2x plus 3 into 1 by 3 will give you 1. So the required quadratic polynomial is 3x square minus 3 root 2x plus 1. Here we have alpha plus beta as 0 and alpha beta as root 5. And then we know that k into x square minus alpha plus beta into x plus alpha beta is the standard form. Now we're going to substitute the values of alpha plus beta and alpha beta. So it's going to be k into x square minus what is alpha plus beta? 0x plus what is alpha beta? Root 5. Right. Now here 0x is nothing but there is no term with the coefficient of 0, isn't it? So this particular term is completely eliminated. So it will be k into x square plus root 5. Since I have no denominator here to cancel out, I am just assuming the fact that k is equal to 1. Then what will be my required quadratic polynomial? My required quadratic polynomial will be x square plus root 5. Then we have 1 and 1. That means alpha plus beta is 1 and alpha beta is also 1. Now again we're going to write it down. K into x square minus sum of zeros into x plus product of zeros. Substitute the values of alpha plus beta and alpha beta. We get k into x square minus 1x plus 1. Again, since I have no denominator here, I'm going to assume that my k is equal to 1 because I have no denominator to cancel out here. So it will be x square minus x plus 1. So my required quadratic polynomial in this case will be x square minus x plus 1. Then I have minus 1 by 4 and 1 by 4. So alpha plus beta is minus 1 by 4 and alpha beta is 1 by 4. Now in this case, again I'm going to write it down. K into x square minus alpha plus beta into x plus alpha beta is my standard form. And now I'm going to substitute the values of alpha plus beta and alpha beta respectively. So I get k multiplied with x square minus, what is alpha plus beta? Minus 1 by 4 times x plus what is alpha beta? It is 1 by 4. Now, right, if you observe in this case, I have 4 as my denominator. So I'm going to let k equal to 4. Then I get 4x square minus, so here minus and minus turns out to be plus, isn't it? So 4x square plus, so 4 multiplied by 1 by 4 is going to give me x again because I have 1x, isn't it? Plus, then 4 multiplied by 1 by 4 is 1. So it's nothing but here I have multiplied the entire equation with 4. That means it is in this way, right? So 4 has been multiplied with x square plus 1 by 4 plus 1 by 4. So it's going to be x square plus 1 by 4x plus 1, and this entire equation is multiplied with 4 because I let the value of k be 4. Then we result in this particular expression 4x square plus x plus 1 because 4 into x square is 4x square plus 4 into 1 by 4x is going to be x and 4 into 1 by 4 is 1, isn't it? Now my required quadratic polynomial is 4x square plus x plus 1. Then we move on to the last sub question in this particular bit and this particular exercise, which says alpha plus beta is 4 and alpha beta is 1. Now again same procedure, isn't it? So it's going to be k into x square minus alpha plus beta into x plus alpha beta. Now again substitute the values of alpha plus beta and alpha beta. So we get x square minus 4x plus 1. And in this particular expression, since I have no denominator, I'm going to let k be equal to 1. So my required quadratic polynomial turns out to be x squared minus 4x plus 1. This is going to be my quadratic polynomial. Hope you all enjoyed watching this video. For more such videos, please subscribe to our channel Smiley Kids. Thank you.